Chapter 9, Section 5 in the 8th grade note-taking guide is entitled Variability. So we're continuing to look at, as we did in the previous section, graphical ways to represent numbers. Not bar graphs and line graphs that take totals and display the totals, but ways we can actually display more numbers, the actual numbers that are in a set of data. Now, this one we're going to study here, a box and whisker plot, which is something you've done before, doesn't quite display every piece of data. It displays some of the data. Bar graphs and line graphs, those are going to display totals type things, maybe not exact numbers. So we're really focused more here on things that display the numbers as opposed to totals and whatnot. All right, so let's take a look at the definitions here. Variability is the spread of values in a set of data. A box and whisker plot is a number line used to show how data are distributed and to illustrate the variability of a data set. The first quartile is the median of the lower half of data. The third quartile is the median of the upper half of data. And the interquartile range is the difference between the third quartile and the first quartile of a data set. And if you're having problems with those definitions, you'll see all these here when we solve a box and whisker plot in a minute. You'll see them, what they actually look like on the box and whisker plot, and it will make more sense. So don't worry if you don't quite understand yet. All right, so taking a look at the first example here, they're asking me to use the data to make a box and whisker plot. So when you're making a box and whisker plot, you're going to start off here like you're finding the median. You want to go ahead and start off and put the numbers in order from least to greatest here, which is exactly what they did in this first box. They put the numbers in order from least to greatest. Now, as you can see, they've given me some other directions here. After I put the data in order, I want to identify the smallest and the biggest value. In case you've forgotten, that's how we're going to draw our lines out to create the whiskers of the box and whisker plot. Those are lines from the graph that simply feed out to the smallest and the biggest numbers. So those are 13 and 25, obviously. So those are going to be where my whiskers lead out to, 13 to the left and 25 to the right. All right, what you want to do now is you want to go ahead and find the median of the entire list of numbers, which is what they're telling you to do right here. So that's going to be, in this case, 19. 19 is the middle number of the two middle numbers here. As you can see, we have 8 numbers on the list, so the middle number would be between 4 and 5. But as you can see, those two middle numbers are 19 here. Well, if I average 19 and 19, no surprise, it averages to 19. So that's going to be my median, which is what they're showing you right here. Now, as far as finding the first and the third quartile, what we're going to do there is find the median of each half now. All right, we've got everything that was less than the median I found. That's going to become like its own list of numbers, and I have everything bigger than the median I just found. That's kind of going to become its own list of numbers. What you want to do is find the middle numbers of each of those sets, and that is called the first and the third quartile. Well, if I take a look at the smallest, it's between 15 and 17, the middle two numbers on just the small side. Well, that's of course going to be 16, which is what you can see they've said right here. On the large side, it's between 21 and 21. Well, we like those type of questions because between 21 and 21 is 21. So the third quartile is called 21. And now I have everything I need to go ahead and make my box and whisker plot. Let's go ahead and drop down to step 2 here. What you want to do is go ahead and make yourself a little number line, and you want to plot everything you just found. So you found the small and the large number, 13 and 25. We put a dot at those. Then we found 3 different medians. We found the median of the entire list, 19, so we put a dot at 19. And then we found the median of the little list on the small side and the little list on the big side, which worked out to be 16 and 21. So we put dots down at 16 and 21. And once we lay all those dots down, then we're going to make the box and whisker plot. The box of the box and whisker plot encapsulates your three medians, your first quartile, your third quartile, and your median. So as you can see, dropping down here from step 2 to step 3, they boxed in these three medians. As you can see, there's a line going through each, so it actually makes a couple different boxes there. Then what you do after you draw your boxes is you create the whiskers. The whiskers draw lines out to the small and the large value 13 and 25, lines that feed out from the box. So as you can see, we have the line going out to 25 on the right and out to 13 on the left. Those are the whiskers, and you've now created your box and whisker plot. Obviously, it fits in with what we've been doing because, again, not only is it a way to represent data, but if you remember, we just did mean, median, mode, and range. Here, looking at a box and whisker plot, it would be really easy to spot the range because we have the difference of the big and the small. We've already found the median because the median is part of the box and whisker plot as well. So it also fits in that vein because that's what we've been working on, finding the mean, the median, the mode, and the range. Now, in case you're having problems still with the first and third quartile thing, that's just a different name for lower and upper quartile. Well, that's what we called them last year. Now all of a sudden they've changed the names on us a little bit to first and third quartile. It's the same thing, it's just a different name for them. Not a big deal. If you still call them lower and upper quartile, you won't have a problem. What you need to know in the homework, when they start asking you about the first quartile, they mean the left side of the box. When they start asking you about the third quartile, they mean the right side of the box. All right, number 2, they're asking me to use the interquartile range to identify any outliers here. So when they're asking me here to identify here the interquartile range, which is a term we did see last year, the interquartile range is really, if we look back at example 1, the box. Anything in the box is considered to be in the interquartile range. So here, looking at this question, the first thing they're telling me to do is figure out what the first and third quartile are, because those numbers represent the box. So once I figure out where the box is, then I know what the interquartile range is. So as you can see, we'll go through that. They put the numbers in order: 65, 72, 75, 76, 78, 79, 79, and 82. Find the middle number, which is the median, which I don't actually need, all right, but it would be here. It would be at 77. Everything less than the median, I'm going to treat as its own little list now. Everything bigger than the median, I'm also going to treat as its own little list. And I'm going to find the median of each of those. So on the low end here, the median is between the two middle numbers, 72 and 75, which is 73.5. So that's right there. On the large end, the middle number is between 79 and 79 here. Well, that's easy. That's 79. Now, technically where it fits is between those two because it's the middle number. But of course, 79 is, of course, itself 79. So where does it fit? It actually fits in there after the second 79 in terms of just number order. Okay? All right, so the interquartile range here is 5.5. That's simply what we get when we subtract our two quartiles, the first and the third quartile, 79 minus the 73.5. Not a big deal.